I write the original expression here. Therefore, x plus I under square root symbol x to the power 4 plus x square plus 1. This expression is expressed in the square form. We use a symbol for 1 cube root. Let minus 1 plus I root 3 by 2 as omega. Good morning, welcome to btosacademy, welcome to my maths class. Students, actually today is the continuation class of the topic complex number. More theories are to be discussed and sums also. First of all, I am going to work out few sums on finding square roots of complex numbers. First I take few sums. To find the square roots. I first write down few sums, then I shall work out. First sum is x plus I under square root symbol x to the power 4 plus x square plus 1. I suggest students, after writing down the expression, you first note the imaginary part. Here we find imaginary part is I into under square root symbol x to the power 4 plus x square plus 1. Already I have discussed that in this part there is two AB I part, this part. For that we see there is 2 is missing. For that I write first bring 2x plus 2I under square root symbol x to the power 4 plus x square plus 1. Now I have got 2AB I form, and this real part will be difference of the squares of two factors of this one, I into this one. For that I need two factors. I first resolve into factors this expression under square root symbol. I first call this 1. Now x to the power 4 plus x square plus 1. You recall this can be expressed a square plus 2ab plus b square. Then the middle term is to be adjusted. That means x square plus 1 whole square minus x square x square plus 1 plus x into x square plus 1 minus x. Now you note the difference of these two factors. You can show that on the right side. What will be the difference? 2x. Now we note there is 2x, therefore from 1 half, we first express these as difference of two factors of this expression. Thus we have got 2x, then 2 into I into square root symbol x square plus x plus 1 into x square minus x plus 1. One by 2. Now this is to be expressed in the form a square, that means root over x square plus x plus 1 whole square, then minus 1, but this is to be expressed in square form, that is why plus I x square minus x plus 1 whole square, then plus 2ab, a and this is b, into I x square minus x plus 1. Thus, in this step we have got a square plus b square plus 2ab form. Therefore, now this can be written as 1 by square root t 2 a plus I square root x square minus x plus 1 put second brackets I write the original expression here, therefore x plus I under square root symbol x to the power 4 plus x square plus 1. This expression is expressed in the square form, therefore require square roots don't forget to write this plus minus symbol. This is the square root, or these are the square roots. Since plus minus symbols are there, therefore two values are there. The first term is solved. Now the second one. In this case also we find 2 AB I is not there. Therefore the second step will be half within brackets 2 minus 2i x square plus 4x plus 3. Then this expression is to be resolved. That can be done easily. You can use the rough space. On the rough space, you show the factorization. I have resolved into factors this expression. If you can resolve mentally, you can do that. Otherwise, my suggestion will be you do that factorization on the right space. Following I have done. Therefore, this will be half. Now 2. You see difference of these two is 2. Therefore, I first write like this. This 2 is to be written as difference of these two factors. Minus 2i into square root x plus 3 square root x plus 1. Now minus of x plus 1, in that place we have to write I square into root over x plus 1 whole square. That is why next step will be half a square form x plus 3 whole square plus I x plus 1 whole square minus 2 into root over x plus 3 into I root over x plus 1. Note that this expression is to be written in this form. That means in square form first. Therefore, it will be 1 by root 2 minus 2ab term. Therefore, minus I root over x plus 1. I put first brackets, then whole square. Written in the form 1 by root 2 within brackets a minus b whole square. Therefore, required square roots plus minus 1 by root 2 . Thus, I have solved or finding square roots of two algebraic expressions. Next, I move to the new concept, finding cube roots of unity. To find the cube roots of unity. Unity means that is 1. You have to find cube roots of unity. In our general knowledge, if you are asked to say what will be the cube root of 1, I think most of the students will answer cube root will be 1. But now let us see what will be the cube roots of 1. First I take, let cube root of 1 be x. Therefore, x is equal to cube root of 1. On the right side, cube root. On the left side, x. To remove that cube root symbol, what to do first? We have to cube both sides. Cubing. X cube is equal to 1. Now I transfer 1 to the left. X cube minus 1 equal to 0. Or x cube, 1 can be written as 1 cube form. Now this is of the form a cube minus b cube. We apply factor form. Therefore, x minus 1 into x square plus x plus 1 equal to 0. Product of two factors 0. Therefore, I get x minus 1 equal to 0 or x square plus x plus 1 equal to 0. From this we get x equal to 1 and x square plus x plus 1 cannot be resolved into two factors. Therefore, we have to use here Sridharacharya formula. I apply that. On the right side, first you write down here a equal to 1, b equal to 1, c equal to 1. And remember that formula, x equal to minus b plus minus root over b square minus 4ac by 2a. According to Sridharacharya formula, x is equal to this. And the equation is in the standard form. In this case, a equal to 1, b equal to 1, c equal to 1. Now, keeping this formula in mind, we write down x is equal to minus b, that means minus 1 plus minus root over b is 1, that is why 1 minus 4 into 1 into 1, 4ac by 2 into 1. That means minus 1 plus minus. The result is minus 3, 1 minus 2, that is minus 3. That can be written as root 3 into I by 2. Now we find 1 cube root is 1, then and other cube roots are minus 1 plus root 3 into I by 2 and minus 1 minus root 3 I divided by 2. Now these are complex numbers, therefore finally we write, therefore cube roots of 1 are first of all 1, then minus 1 plus minus root 3 into I. I suggest students be careful while you are writing root 3 into I. Generally, in some cases I find students write root over 3i, not that, root 3 into I. If you feel confusion, you can write I before root 3. That means I root 3 by 2. Now these are the cube roots of unity, and this one is real and these are complex. Therefore, we can comment that cube roots of unity will be one real and the two other complex roots. Now we are going to find interesting relationship between these two complex cube roots of unity. First of all, we use a symbol for one cube root. Let -1 plus I root 3 by 2 as omega. That is a Latin letter omega. Now I square this one. Therefore, 1 omega square is equal to, denominator will be 4 minus 1 plus I root 3 whole square 1 minus 2 I root 3 minus I root 3 whole square, that will be minus 3 by 4 minus 2 I square root 3 by 4. Taking 2 common factor and cancelling, finally we get minus 1 minus I root 3 by 2. Therefore, omega square minus 1 minus I root 3 by 2. We took minus 1 plus I root 3 whole divided by 2 as omega. Squaring, we find minus 1 minus I root 3 whole by 2. That is the other complex cube root, which is the other complex cube root of 1. That means if we use omega, then therefore cube roots of 1 are, 1 is the real and 2 other will be omega and omega square. Here I have taken minus 1 plus I root 3 by 2 as omega. Now you can find yourself, if you take minus 1 minus I root 3 by 2 as omega and square that, you will get minus 1 plus I root 3 whole by 2. That means we can say one complex cube root is square of the other. Relation one complex cube root of 1 is square of the other. We can write that remark, relation as well as remark. Now we have solved the equation x cube equal to 1, got roots 1, omega and omega square. Then we can say omega is a root of also omega is a root of x cube equal to 1. Therefore, that will satisfy the equation. Therefore, omega cube is equal to 1. Again, after resolving x cube minus 1, we got x minus 1 into within brackets x square plus x plus 1, and from that we wrote that either x equal to 1 or x square plus x plus 1 is equal to 0, and from the later one we got two roots omega and omega square. Therefore, omega is also a root of x square plus x plus 1 is equal to 0. Again, omega is a root of x square plus x plus 1 equal to 0. Then omega will satisfy this equation. Therefore, omega square plus omega plus 1 equal to 0. Therefore, we got two more relations related to omega. First one, omega cube equal to 1. The second one is omega square plus omega plus 1 is equal to 0. Now let us work out few sums related to omega. We shall prove number 1, product of these factors equal to 9. First, for 2n factors. There are 2n factors, the value will be 2 to the power 2n. Now, number 1. First, let us express these two factors in lowest term using omega cube equal to 1. Now, 1 minus omega to the power 5 is equal to 1 minus omega cube into omega square. That means 1 minus omega square. Since omega cube is equal to 1, I will suggest students, learners, to mention on the right side this thing. Then 1 minus omega to the power 10, that is equal to 1 minus omega cube whole cube into omega. That means 1 minus omega. Therefore, left hand side 1 minus omega, 1 minus omega square 1 minus omega square into 1 minus omega. For this one, 1 minus omega square, and for this one, 1 minus omega. Therefore, we get these two same, 1 minus omega whole square into 1 minus omega square whole square. Now, we expand 1 minus 2 omega plus omega square, 1 minus 2 omega square plus omega to the power 4. Now, we use 1 plus omega square equal to 0. Here I mention that first, since 1 plus omega square equal to 0. 1 plus omega square, there is minus 2 omega, therefore minus 3 omega. And for this, 1 minus 2 omega square, omega to the power 4 means omega cube into omega. Putting omega cube equal to 1, that will be omega. Now this is 0, minus 3 omega. And for this part, 1 plus omega square, there is minus 2 omega square, therefore minus 3 omega square for adjustment, minus 3 omega into, this is 0, minus 3 omega square, minus 3 into minus 3, that means 9 into omega cube, finally 9. Therefore, the value is 9. The sum is solved. You note, I suggest students, you take sums from your textbook and practice. Remember, you are to use 1 plus omega square equal to 0 and omega cube equal to 1. Now we move to second sum. First of all, we follow, there are 2n factors. First 3 factors have been written. For solving that, we first simplify each of these 3. Then the whole is to be discussed. First one. Now, 1 minus omega plus omega square. We know 1 plus omega square equal to 0. Keeping that in mind, we rewrite this 1 plus omega square minus 2 omega. This one is 0, that means finally 2 omega. First factor is minus 2 omega. Then we calculate the second one, 1 minus omega square plus omega to the power 4. That is equal to 1 minus omega square plus omega to the power 4 means omega into omega cube equal to 1. Now this can be written as 1 plus omega plus omega square minus 2 omega square. You can put brackets here. Then 0 minus 2 omega square minus 2 omega square. Then I find third one, 1 minus omega to the power 4 plus omega to the power 8, that is equal to 1 minus omega to the power 4 means omega cube into omega, therefore this will be omega plus Omega to the power 8, that can be written as omega cube whole square into omega square. That means 1 minus omega plus omega square. We have got this one, therefore this will be equal to minus 2 omega. I have this one. Therefore, LHS. We now put the simplified values for this minus 2 omega, for this one minus 2 omega square, for this one again minus 2 omega. The successive values will be minus 2 omega square dot 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 2n factors. Now we follow that minus 2 omega is occurring how many times? Since there are 2n factors, therefore minus 2 omega will occur n times, and the remaining, that is minus 2 omega square, will occur also n times. Therefore, I can express that minus 2 omega whole to the power n into minus 2 omega square whole to the power n. Minus 2 whole to the power n minus 2 whole to the power n, that means 2 to the power 2n into omega into omega square to the power n. Follow minus 2 whole to the power n into minus 2 whole to the power n. Remember that identity, a to the power n into b to the power n equal to ab whole to the power n. Now a is minus 2, b is minus 2, therefore their product will be 2 square, then whole to the power n is there, 2 to the power 2n, 2 to the power 2n, omega into omega square, omega cube, that is 1, therefore finally 2 to the power 2n, that is the RHS part proved.